Okay. Which one, Ms. Bachman?
Number...
7?
Number 12 is
Oh,
one that they're like...
okay, we'll take a look at that
They're trying
one
to figure
later.
out how to put that up.
Okay. All right, folks, let's look at number 5. Okay, this one hopefully should be pretty easy for us. It's another construction. Okay, but now the question has changed on us. In number 4, we were asked to describe which of the following is not a step to bisecting an angle. Now in number 5, we're asked which of the following shows the correct markings to construct a perpendicular bisector. So only one of these is showing the correct markings for a perpendicular bisector. Melissa? D is correct. You can see here that it has like the basic markings of the football construction. It just didn't continue to make it, but D is the correct answer there. That is right. Okay. A is the markings for what kind of construction? Angle bisector. B is, I have no idea what that is. That is made up. And then C, that's not something that's not a construction either. It's D that is perpendicular bisector. You can see they're drawn to the angle there. So anyway. All right, number 6. Let's look at this one. All right, so we got triangle ABC has vertices A, 1, 1. There's A. B, 6, 5. Right there. And then C, 2, negative 2. So there's C. And so I connect those dots. By the way, folks, on your CRES, this will be a lot bigger. I put this in half so I could save them on paper there. Okay? Sorry, I put 2 pages per sheet to kind of like save on paper. So anyway, there's triangle ABC. Triangle ABC will be reflected across the line x equals 2. Now, some of you ask me, where is x equals 2, or where's the line x equals 2? Well, if you think about it, here's the x-axis, right? Here's 2 on the x-axis, right? So remember, this point also has an x-coordinate of 2, though, right? So does this point, so does this point, so does this point. All these points along this vertical line here have an x-coordinate of 2, and so that is our line of reflection right there, this vertical line. Okay? It asks us to reflect this triangle over this vertical line here, x equals 2. Which quadrant will not contain a vertex of triangle A prime, B prime, C prime? Well, let's see here. So B, it's 1, 2, 3, 4 way this way, so we'll go 1, 2, 3, 4 way here. There's B prime. C is on the line of reflection, so where does it reflect to? The same place, because it's on the line of reflection. A is 1 to the left, so A will reflect 1 to the right. And there's our new triangle. So which quadrant does not contain a vertex?
3.
Be careful how you number. This is 1. This one is 2. 3 does not have one. The third quadrant. The third quadrant. Yeah. I know. Why does it go counterclockwise instead of clockwise? No idea. No idea. Yeah. 1, 2, 3, 4. Okay? All right, number 7. I'm not a huge fan of this question, but so it goes. The answer here for number 7 is D. Let me explain why. Let me explain why. Listen up, please. Okay. Let me explain why these other ones are not the real ones. Okay, so for example here, which of the following theorems or definitions is the missing reason? So if we start here, okay, AB is congruent to AC is congruent to BC. So we're starting with our 3 sides here being congruent, and then we jump down to 2 angles being congruent. So you might be tempted to say, oh, Mr. Widmeyer, we're saying angles are congruent. That's the definition of congruent angles. The definition of congruent angles is that if 2 angles have the same measure, then they are congruent. Did we establish that B and C or A and C have the same measure before this? No, we didn't. So we cannot use this, okay? Yes, we're saying things are congruent here, but that's not the definition of congruence. The definition of congruence is if 2 things have the same measure, then they're congruent, okay? Letter B, corresponding parts of corresponding triangles. Okay, is that CPCTC? Yeah. CPCTC is corresponding parts of congruent triangles are congruent. And we only have 1 triangle here, so nope, it can't be B. Okay, there's not 2 congruent triangles there. Letter C, triangle sum theorem. What's the triangle sum theorem?
Isn't it when you add
not the sides. The angles. If you add all three angles of a triangle, they add to 180. That can't be that, because we're not adding any angles up to 180 here. It's letter D. Now, you might be wondering, Mr. Woodmeyer, why? This triangle here is not isosceles. Shh. Listen, please. This triangle is isosceles. The definition, Robbie, listen up. The definition of isosceles triangles is not exactly two sides are congruent. The definition of isosceles is that at least two sides are congruent. Are at least two sides congruent here? Yes. So this is an isosceles triangle. The base angle theorem then says, Eli, the base angle theorem says if two sides are congruent in a triangle, the opposite angles will also be congruent. So since AC, for example, is congruent to AB, that means angle B and angle C are going to be congruent. You see it? That's the reasoning there. AB is congruent to AC, so therefore B and C will be congruent. And similarly, AC is congruent to BC, and so that should be A and B are congruent there. But anyway, okay, so it's isosceles triangle base angle theorem. All right, number 8, last one here. Quadrilateral ABCD is graphed on the XY coordinate plane below. After translating quadrilateral ABCD, C prime is located at -2, 3. So let's see here, -2, 1, 2, 3. There's where C prime is now located. What kind of translation do we have to do to go from this C, original point C, to C prime? How do we have to travel? So if we count here, let's just count, right? Yeah, 1, 2, 3, 4, 5, 6 to the left, and then up how much? 2. Well, which one of these is showing 6 to the left and up 2? It's got to be C, right? X minus 6 means you go left 6, Y plus 2, up 2. So there it is. C is the answer. Does that make sense now? You see?
No, I got the same answer. I just didn't.
Okay, you did it in a different way? All right. If you could also guess and check each one of these to see which one gets you to the correct point, too. All right, so we're going to stop there. All right, I want you guys to keep working here. Okay, on the next section, we'll go over the rest of these questions tomorrow, though, not today. Okay.